I see he was counting down. Making a YouTube video in this
Okay, so increasing, decreasing functions. So we're going to use the first derivative test to find our relative extremas. Okay, so instead of finding just absolute stuff, we're going to find potential relatives. So they give us this nice little chart for procedures of how to find where a function is increasing and decreasing. We did do this last year a little bit with the number line test. Remember where you fill in if it's positive or negative? You remember, right, Hunter? Okay, so first thing that you have to do is find the domain restrictions. Okay, it becomes very important to know where your domain restrictions are because it is possible that, number one, your function just might not exist between a certain interval, or you might have holes and vertical asymptotes. Okay, so remember, functions are not differentiable when the function is not continuous, and that happens when you have domain restrictions. Okay, so step 2 is then finding your critical values. How do you find a critical value? Set your first derivative equal to 0. It says it right there, by the way. Take your first derivative, set it equal to 0. Remember, you're looking for when the function is undefined as well. Okay, that's important too. Okay, so then number 3, we're going to locate the critical numbers and the domain restrictions on a number line. So we're going to do this number line test, and then we're going to see if it's going to be positive or negative, and that tells us if it's increasing or decreasing. Yeah. Okay, so question number 1 says to find the intervals on which these functions are increasing and decreasing, and then we're going to find the local extrema points. Okay, so if we're going to find points at the end of the problem, we should have an x and a y, right? Super. All right, so first thing I have to do is, do I have any domain restrictions for my first question? Is there any value that x cannot be? No, we do not have a square root piece involved. We have a cube root, okay, but cube roots are okay. You can take cube roots of negative numbers. There is not an x in the denominator, so we're good there. So no domain restrictions. So we're going to go straight into finding our critical values. So how do you find critical values? Derive it. Okay, so step 1, we are going to derive this function. Okay, which rule are we going to use in order to derive it? Mike, you with me?
Yeah.
I'm up here.
Yeah.
Hey. There you go. Okay, so chain rule. What number is going to go out in front? 2/3. And then I write the quantity, and then I lose 1 on my exponent, so 2/3 minus 1 is now going to be negative 1/3. And on the test, a lot of you guys forgot this hook-on factor, by the way. Okay, so after you derive the outside, you got to derive the inside. So what's the derivative of the inside? 2x. All right, so at this point, I'm going to simplify. I have a 2 in the top, I have a 2x in the top, and I have a 3 in the bottom, and I'm going to throw that quantity down because it has a negative exponent. So I'm going to combine the 2 and the 2x to make a 4x, and then I'm going to put that quantity downstairs with the 3 and turn that exponent positive. Thank you. All right. So now I'm trying to find critical values. So I set the derivative equal to 0. Okay, so immediately I look at this and say, I have an x on the top and I have an x on the bottom. Okay, so I'm going to have a slope of 0 at some point. Which point, by the way? At 0. And then I'm also going to have an undefined slope when that denominator piece is equal to 0. Okay, what values makes that denominator equal to 0? 3 and negative 3. Okay, so we end up with critical values, or critical numbers.
No, gosh.
At 0 and plus or minus 3. Still okay? Okay, so once we have found our critical values, the next step is that we're going to do our number line test. Okay, so the number line test is where we take all of those critical values. So we take negative 3, 0, and positive 3. And all we're trying to do is figure out if the function has a positive derivative or a negative. Okay, so remember that the derivative is analyzing the slope. Okay, so like if it's going up or down, so we can figure out when it's increasing or decreasing. Okay, so remember that this is getting tested into the first derivative. Okay, so if I have a value that is less than -3, such as -4, if I plug -4 into, I like this one right here because it's simplified more. Okay, so imagine putting -4 in there. On the top I get a negative, right? The bottom is going to be positive because you'll get 16 minus 9. So negative over positive is a negative. Good. Okay. Now give me a number between -3 and 0. -2 would work? Okay, -1. Sure, either of those are fine. If I plug -1 into the top, I'd have a negative. If I plug negative into the bottom, what would I get? I would get a negative because you could get 1 minus 9, which is a -8. So I'd get a negative on the bottom. So I get a negative over a negative, which makes a positive. Okay, give me a value between 0 and 3.
2.
1 or 2 would lose. 1 is perfect. So if I plug 1 in, I would get a positive on the top, a negative on the bottom. Positive over negative is a negative. Okay, my last interval, I need a value greater than 3. 4 would work. So if I plug 4 in, I get a positive on the top, a positive on the bottom. Positive over positive is a positive. Okay, so can you tell me where this function is increasing or decreasing? Let's start with, where is this function increasing? Okay, so here's a question for you. Do I include the value of -3 and 0 on that first interval? Do I include them? No, why not? Because, yeah, the critical values are where the slope is 0, and at 0 it is not increasing and it's not decreasing. So we do not include the critical values. Okay, so then 3 to infinity. Okay, where is this decreasing? Okay, I'm going to say -infinity to -3, although what you said was just fine. 0 to 3. Oops, I forgot that. Okay. So we got increasing, decreasing, and it says find the local extrema points. Okay, so how do I know where my extremas are? Okay, yeah, they're at our critical number. So basically what I know from this number line test is this function goes down, then it goes up, it goes down, and it goes up. Okay, so I can tell you that if I graph this on a calculator, it's going to have a W effect. Okay, I can't really describe the curvature yet, so it's probably more curved than what I drew. But I know that there's going to be, what's going to happen at -3? Is that a min or a max? That's a min. So I can say, hey, we got a relative min. Well, actually, I don't know if it's going to be a relative or absolute at this point because it could be. So it's going to be a min. We'll figure out later after we find its corresponding y value which one it is. So how am I going to find the corresponding y value? Good, back to the original, right? So if I go back to the original and plug -3 in, we get 0. Okay, let's find the other potential min and see which one is lower. So the other one would be at 3, right? If I plug 3 in, I get 0. So what kind of values are they? Are they absolute or are they relative?
Relative.
Okay, so relative means there's a point that exists below it.
Oh, no, they're absolute.
Then they're absolute, right? Okay, so they're absolute. There's no other point that exists below them. Okay, so that's going to make 0 a max. And by the way, what kind of max? Relative. It's a relative. Okay, because the function, like those two ends are going up, it's like that W effect. It keeps going up forever. So there is a point that does exist above it. Okay, if I plug in if I plug in 0, I get negative 9 squared first, so that's what, 81? And the cube root of 81 is the cube root of 81. I don't know what that decimal is, but there you go. I'm going to leave it as that. So, yeah, that's what I was kind of just thinking, like, wow, okay, we got a little bit of work to do. Oh, yeah?
Yeah, I agree.
Well, we'll see. Well, let's give number 2 a try, and we'll talk about the problems afterwards.
Number 2.
Alright, so question number 2, what is the first thing that we do? Before that, we gotta check the domain. You gotta check domain first because we have an issue on this one. Okay, this one says that x cannot be 0 because what happens? There's a vertical asymptote. Okay, so that should help you kind of think like, oh yeah, we got a vertical asymptote. The function is splitting apart. We got this like, I don't know what's happening there, but something at 0. We got a vertical asymptote there. Okay, so now we're going to derive it. Which rule are we going to use in order to derive this? Okay, so what do you start with on quotient? The whole. So the whole is 3x. What's the derivative of the high?
4x.
4x cubed minus the high, x to the 4th plus 3, times the derivative of the whole, all over the whole squared. So on the top we end up with, what is that, 12x to the 4th? Distribute the 3, so 3x to the 4th minus 9. On the bottom, if I square the 3 and the x, my bottom is going to be 9x squared, right? So I'm going to end up with, let's see, 9x to the 4th minus 9 over 9x squared.
Take out a 9.
You can take out a 9. So yeah, x to the 4th minus 1 over x squared. So if I set that equal to 0, what are my critical values? 0 from the denominator, and then if I set the top equal to 0, this 4th root of 1 is 1, so plus or minus 1 though, right? What's that? Just setting the top equal to 0, because you add 1 and then take the 4th root of 1.
Because she's smart, Faith.
Alright, so now we do our number line test. Yeah. They should have given us more space. Alright, so I need a value. Remember that we're checking it against my, so we're going to use that last simplified derivative. So if I plug negative 2 in, I'm going to get a positive over a positive, right? So positive. If I plug, negative 1/2 in, you're going to get a negative on the top, because if you subtract 1 from a fraction, and the bottom will be squared, so it's positive, so we get, a negative. Okay, what about if you plug a positive 1/2 in? So you get you get a negative, because you get, on the top you get a fraction minus 1, which is a negative. And then, okay, and then if you plug 2 in, you're going to get a positive. So this goes up, down, down, up. Not an, there is an asymptote. I was not going to say, yes, there's an asymptote. So probably what this function looks like is one of those, it probably looks like this. It probably has a slant, it has a slant asymptote and looks like this. Kind of an hourglass-ish. Something like that. Okay. So this function is increasing from negative infinity to negative 1. and from 1 to infinity. It's decreasing from -1 to 0 and 0 to 1. Make sure you write those as separate intervals because it does break apart. Okay. What's happening at -1? Is it max, a min, relative, or absolute? You guys with me? Okay, it's a max. Do you guys see how when I draw my slopes like this? Up, down, that's a max. Like it's literally showing the max.
Yes.
Okay, so it's a max. Is it a absolute or relative? Okay, relative because there's more function that exists above it. So it's a relative max. Max. At -1, so how do I find the corresponding y value? So 1 plus 3 is 4. 4 over -3, right? -4/3. Okay, tell me what happens at 0. It's an asymptote, so is it a max or a min? It's neither, right? It's a asymptote, it doesn't exist there. So that's not part of our extremas. But then at -1 we have a relative min. Good. Okay, and if I plug 1 into that one, I should get 1 4/3. Well, we only have 3 problems for examples, so that's good. Alright, let's do 3 and then we'll take a look at the assignment, okay? Alright, so question number 3, do I have any domain restrictions?
No.
Nope, so I go straight into
deriving
function. What is the derivative? 3x squared minus 6x plus 3. So then if I set that equal to 0, I can pull a 3 out and then we can do an easy method on this. Plus 1. So the 3 goes away because it's set equal to 0. What two numbers multiply to 1 and add to -2? -1 and -1, so I can say a -1 squared. So I end up with 1 critical value. What is my 1 critical value? If I set x minus 1 equal to 0? 1. But the 3, you can just divide the 3 to the other side. So 0. But the 3 doesn't have an x with it. You need an x to have a critical number with it. Nope, just plain 1, because there's no plus or minus. Because we just said x minus 1 equal to 0. Because the squared, if you have the whole thing set equal to 0, you'd square root it. So if it's set equal to 0, square root of 0 is still 0. Right? Okay. So to find where it's increasing and decreasing, plug in a value less than 0. So by the way, we're plugging it into this. So let's say 0. So if I plug 0 into that, I would get 3 times 1. So I get a positive, right? And if I plug a value bigger than 1, such as 2, I would get 3 times 1 again. Yeah, you're right. Positive, positive. Okay, so can you tell me what this looks like? If it's x cubed, x cubed. What is a x cubed? It's a John Travolta. So what is happening at the x value of 1?
Just doing the little.
Okay, yeah, it's where it levels out, kind of like where the head of the John Travolta is. So for an instant, its slope is 0, right where his head is. Okay, so that's actually called a point of inflection. We'll talk more about that later. But it is 0, so we can say that this function is increasing From where to where? Okay, yeah, from negative infinity to positive infinity, it does increase. It never decreases. No. Decreasing. Do we have a min or max?
Who knows?
Right. There is no min or max. No. Wow, that's not very weird. All right. So let's just double check what this says because they're probably going to ask you questions about this wordage. So it says in example number 3, the function is strictly monotonic. Okay, what does strictly monotonic mean?
Strictly increasing.
Yeah, you just doing one or the other.
Okay, so it's just only increasing or it's only decreasing. Okay, so strictly increasing or strictly decreasing, okay, is monotonic. Okay, so 2 examples, or example 3 actually is 2 important points. Not every critical number will create a min or a max. Okay, which we kind of noticed that too in that last example where we had a vertical asymptote. Okay, and even though the slope is 0, that doesn't mean that it takes away that increasing piece. Okay. Okay. So, actually, a lot of this is not as bad as